The last thing we're going to do with factoring this year is something called the difference of squares, or the difference of two perfect squares. This is a sort of a unique method of factoring that only works with very specific numbers, and we're going to talk about that in just a minute. But go ahead and find this page in your notes. It should be your last one in the notes packet. And you'll see on yours that you actually have like 3 different things listed here. The difference of squares is the only topic we're talking about today. So you're actually only going to be filling out 1 box in your notes packet. And then the other 2 boxes you just won't be doing at all. This first slide does not appear in your notes, okay? This slide I'd really like you to just kind of follow along with me, pay attention, and then I'm going to ask you a couple questions about it in a minute, and then we'll get on to the examples. So let's say I ask you to factor something like this, x squared minus 25. Well, thinking about the ways that we've factored so far, it doesn't have a GCF, there's nothing I can pull out, and it's not a trinomial, okay? But I could make it a trinomial if I so desired. What's missing from this, usually we have x squared plus something x plus something. So it's that x term in the middle that we're missing. So I'm going to write this with a 0x in the middle. And just like that, whoops, except that wasn't a plus, was it? The 25 has a minus in front of it, so that should be a minus. Just like that, now I've got a trinomial that I can work with. So when I go to factor it, just like we've been doing, I know I'm going to start with an x and an x. Looking at this, I know my signs are going to be a positive and a negative. And what I'm looking for is 2 numbers that multiply to 25 and subtract to 0. Remember, subtract, because when you add a positive and a negative, it's really like subtraction. So for 25, that would be 5 and 5. And so this is the factored form of that, okay? And we're going to kind of generalize that in just a minute. But I want to point out a couple of things. It's important that this is a negative, okay? Because that being a negative is what made it so that we had 1 plus and 1 minus. Had that been a plus in between there, I would have had to work with 2 plus signs here, and then I never would have been able to combine 2 numbers to make 0, because you can't add 2 positive numbers together and have them equal to 0, okay? To make them equal 0, you have to have 1 number be positive and 1 number be negative so they can cancel each other out. The other thing that's important to notice is these 2 numbers would have to be the same, okay, for this to work. Because if I want it to add to 0, I've got to have a positive something and a negative something that are exactly the same. That's how you get them to cancel out and equal 0. If that was a 4 and a 6, they wouldn't cancel. So if these 2 numbers have to be the same, think about what kinds of numbers this is allowed to be. This number has to be a number that could be factored into 2 of the exact same numbers. So to show you what I mean by that, like for example, 36 could be factored into 6 and 6. So this would work. I could do something like this if this number were a 36. 49 can be factored into 7 and 7. So I could do this same process with a 49 here, because I could do a positive 7 and a negative 7. However, something like 20 would not work, because there's no way to make 2 of the exact same number equal 20 without decimals, okay? So what these numbers really are perfect squares, okay? And that's why this is called difference of squares. The numbers that would work for this process have to be perfect squares, because you have to be able to get 2 of the exact same number so that they can cancel each other out and make this 0 in the middle, okay? So that's how this process works. You're going to go ahead to the next slide in Nearpod. You're going to answer a couple of questions, and then we'll come back and work through the examples that are in your notes packet.